Welcome. So, you've been handed a project that needs a truly insane amount of compute power on AWS. You know the feeling, right? It's not just about spinning up a bigger server, it's about architecting a solution that's powerful, but also smart and cost effective. Today, we're going to build a decision making guide for exactly that. Okay, so the request lands on your desk. Maybe it's for some groundbreaking AI research, a new blockbuster film, or a super complex financial model. Whatever it is, the compute needs are just astronomical. It basically needs a supercomputer. And as the architect, it's on you to figure out what that actually means in the cloud. So, where do we even start? Let's dive in. Here's how we're going to break this down. First, we'll talk about the challenge itself. Then, we'll pop open the AWS toolbox and see what's inside. After that, we'll get into the fun part, matching the right tool to the right job, cover some critical design factors you just can't ignore, and then we'll wrap up with the 3 key questions you have to ask before you deploy anything. All right, first things first, let's set the stage, because we're talking about a completely different class of problem than your typical web app. These aren't just resource-intensive tasks, they're often the absolute core of a company's innovation or a project's success. The cost of getting the architecture wrong here, not just in money, but in time, can be absolutely enormous. This is where precision really, really matters. So how do you even begin to tackle these massive universe-scale problems? Well, AWS gives you a whole set of highly specialized tools. The secret is knowing which one to grab for the job at hand. At a really high level, your choices fall into 3 main buckets. You've got raw HPC instances for those really tightly coupled jobs. You've got specialized GPU instances for accelerated tasks, and then you have managed services that pretty much handle all the orchestration for you. The key thing to see on the slide is that constant push and pull between control versus simplicity. Let's break each one down. So, HPC instances. Think of these as your build-it-yourself supercomputer kit. This is for things like computational fluid dynamics or weather modeling, where you've got thousands of cores that all need to talk to each other, like instantly, over a super fast network. You get maximum control, which is great, but it also means you're on the hook for managing every little piece of it. Now, GPU instances, these are the specialists. They are the race cars of the compute world. They're designed to do one thing incredibly, incredibly well, perform millions of identical calculations all at the same time. This makes them absolutely perfect for training AI models or rendering complex visual effects. And finally, you've got managed services. Think of tools like AWS Batch or Amazon SageMaker. They're like an orchestra conductor. You just give them the job, and they handle the whole complex dance of spinning up servers, managing queues, and scaling the cluster. This is what you choose when you want to focus on your science or your code, not on the infrastructure. Okay, so we've looked at the toolbox. Now for the real work. How do you actually match your workload to the right service? Let's make this real with a super common example. Training a machine learning model. It's a classic compute-heavy task, right? You're feeding just massive amounts of data into an algorithm, and the architectural choice you make here can totally change your team's speed and your project's final bill. So for that ML training job, do you use raw GPU instances from EC2, or do you use a managed service like SageMaker? This slide shows that core trade-off perfectly. With raw instances, you get total control. You can build this completely bespoke environment, but you pay for it with a lot of operational headache. With SageMaker, you get pre-built environments and tools that just get you moving faster, but you do give up a little of that fine-grained control. The right choice here depends completely on what your team needs. But just choosing the compute service, that's only the first step. To build a truly great architecture, you have to fine-tune it, and that means thinking about a few other critical factors. First up, let's talk about money. On-demand instances give you that guaranteed capacity at a fixed price, which is nice and predictable. But then you have spot instances. They use AWS's spare capacity and can save you up to 90%. So what's the catch? Well, it's a big one. They can be terminated with just a 2-minute warning. The bottom line is this. If your workload can handle interruptions, using Spot is the single most powerful cost-saving lever you can possibly pull. Next, please do not let your expensive compute instances just sit there doing nothing. You have to make sure your storage can feed data fast enough to keep those GPUs busy. And if you're running a multi-node job, your network has to be fast enough for them to talk to each other efficiently. A bottleneck in either of these means you are literally paying for expensive hardware to sit idle. You're just burning money.
So, to bring this all home, let's frame everything as a final checklist. Before you commit to any design, I want you to step back and ask yourself a few fundamental questions. First, where is the real bottleneck? Is it compute? Is it storage? Is it the network? Because if you spend a fortune on compute, but your storage is actually the slow part, you've just solved the wrong problem and wasted a ton of cash. You have to find the true limiting factor first. Second, and you gotta be honest with yourself on this one, how much control do you really need? Does your team truly need to manage every single library and driver, or would a managed service let them get their job done way faster? This is that classic build versus buy decision, just framed for the world of cloud computing.
And finally, the all-important question of resilience versus cost. Can your job tolerate interruptions? Can it be paused and resumed? If the answer is yes, you have a massive opportunity to dramatically slash your costs with Spot. If not, then the guaranteed availability of on-demand is your only safe path forward. Answering these 3 questions, really thinking them through, will guide you to the right architecture every single time.